Today we're going to talk about explicit arithmetic sequences. So an arithmetic sequence has two different formulas, the explicit formula and the recursive formula. So tomorrow we'll talk about recursive, but today we're going to talk about the explicit formula. So Sandra needs to buy t-shirts for her club at school. She found that a company charges her $30 for the first shirt and then charges $10 for each additional shirt. So we want to plot a point for the amount of money she would spend if she bought between 1 and 5 shirts. So we know for one shirt, she spent $30. For 2 shirts, we're charging an additional $10 for each shirt, so $40. For 3 is $50. 4 is $60, and 5 shirts would be $70. So we're going to plot these points: 130, 240, 350, 460, and 570. All right. So the way sequences work, we're not going to connect these dots because with sequences, we're only looking at whole positive numbers. In this case, we're talking about where X is represented by t-shirts. And so we can't have a decimal number of t-shirts. We can't have 1.5 shirts. And so when we look at this graph, if we were to connect it, that means we can have 1.5 shirts, we can have 2.5 shirts. It also means it goes on into the negatives forever. So we don't want any of that. So with sequences, we leave it unconnected because we only want whole positive numbers starting at 1. So notice in our word problem, it says $30 for the first shirt. So whenever you see the word first, or if you see something like month 1, so if you see like first month or month 1, that's going to indicate that it's a sequence. So a sequence starts at 1, whereas usually with a linear equation, it would start at the y-intercept. In this case would be 20, right? So a linear equation starts at 0, but sequences start at 1. So that's a big difference between sequences and linear equations. So anytime you see the word first or 1, that's going to indicate that it is a sequence instead of a linear equation, even though these look very similar because we can tell by the pattern that this is adding 10 each time. So it has a constant rate of change, just like linear equations. So we're going to look at some of the similarities and the differences. So arithmetic sequences look like linear equations. When we graphed it, it was in a straight line. We saw that there was a constant rate of change, just like with linear equations. And in a minute, we're going to write the formula. And our formula has no exponents, just like with linear equations. All right, however, arithmetic sequences are different from linear equations in a couple ways as well. So with sequences, we're looking at whole positive numbers. So another thing that we looked at is where the equation starts. And so with an arithmetic sequence, or any type of sequence, it's going to start at 1, whereas with the linear equation, we always started at the y-intercept, which is at 0. So arithmetic sequences are going to start at 1, not at the y-intercept, which is 0, right? And in a word problem, what we would look for to indicate that it would be an arithmetic sequence instead of a linear equation, we would look for words like first or one. And that would alert us to the fact that this is a sequence and not a linear equation, because it's going to start at 1 and not at 0. So when we look at our formula, we're going to see that in our formula. So an explicit formula helps us find any term in the sequence. So if we want to find the 10th term, we're going to plug in a 10 for our variable. So we start out a sub n. This is the same as y equals, right? Also the same as f of x equals, right? Just another way to indicate what the sequence is called, or this equation. And this is our term value. So this is the actual numbers in the sequence that we see. Next is our first term, a sub 1. Then we have d. This is our common difference. And this is the same as our slope. It's just how it's changing. Is it going up or going down? That's what our common difference represents. Then we have parentheses, n minus 1. So n is the same as x, and that's our term placement. So what that means is where it comes in the sequence. Is it first? Is it second? Is it third? If we want to find the 100th term, we plug in 100 for n, because that's where it comes in the sequence. All right, so remember that a linear equation, our formula is y equals mx plus b. So we have our change, and we have our starting amount. So here we have our change and we have our starting amount. The only difference is it's not just our change times our variable. It's our change times our variable minus 1. And that indicates that it is a sequence, because remember, this is starting at 1 and not 0. So our formula has to account for that. And in our formula, we have to back it up. And so we say n minus 1 to back up our sequence so that it actually works with the numbers we are given. All right, so when able to write an explicit formula, all we need is our first term and our common difference. So just like linear equations, you need what it's changing by and where it starts. And then we just distribute and combine like terms. So we're going to use this sequence that we started with. So 130, 240, 350, 460, and 570. So our first term is 30 because we started with one shirt and that cost $30. And then our common difference is 10 because we are increasing by 10 each time. So we start with our formula, a sub 1 plus our common difference times n minus 1. And we're going to plug in these two numbers. So our first term is 30. Our common difference is 10 times n minus 1. We're going to distribute. We get 30 plus 10n minus 10. Then we combine like terms. 30 minus 10 is 20 plus 10n. And this is our simplified explicit formula. All right, so then sometimes they ask you to find a certain term. So we need to find the term number. If they're asking us to find the nth term, so they'll say the 10th, the 11th, the 12th. So any term number, we need to find out what term number we are finding, and then we're going to plug that in for n. So frequently they will write it as find a sub 15. And that means we're finding the 15th term. And so what we do is we say a sub 15 equals, and then we take our formula and we're going to plug in a 15 for n. So we would have 20 plus 10 times 15. That would give us 170.